Hi everybody, welcome to my virtual trip here at Tides Europe in Brussels. It's day 2, November the 16th. I'm delighted to be joined by my good friends at Bioworks and Johan Persäter, who is going to give us a quick overview on Bioworks and also how the event's been going this week. So first of all, Johan, lovely to meet you. How are you?
Hi, it's lovely to meet you. I'm doing great. What a great event.
Brilliant. So, Johan, before we start talking about Bioworks, how has Tides been? I mean, this is day 2, so how was day 1?
Day 1 was absolutely amazing. A lot of good meetings, a lot of good conversations. So good to see everything that is going on in this field, oligo and peptides.
Brilliant. Now, for those people not familiar with Bioworks, can you give us a quick overview of the business?
Absolutely. So Bioworks is an innovative Swedish company manufacturing and developing agarose resins for chromatography.
Right.
And agarose resins is a material used for separation and purification of biomolecules.
Right.
So what we do is we have gone back to basic, made a stronger bead, which means we have the same product that has been on the market for a long time, so it's same but different. Better flow, better purity.
Brilliant. Now, I know you've been really busy over the last 18 months, and the company's grown quite a lot. So can you talk about some of the developments that's happened at Bioworks over the last 18 months or so?
Absolutely. Well, there's always developments going on at Bioworks. So right now we have a strong focus on peptides and oligos, and we have a lot of products in the pipeline. But also we have worked a lot on the production capacity and doubled our capacity. So it's been a great year for us, despite of the COVID.
Right, and this week at Tides Europe, what have you specifically been talking to delegates about?
So we have talked about our great resins for oligo and peptide purification, that we have a really good resin with a unique combination that gives a unique combination of purity and yield, and that we really would love to make customized resins for their specific needs.
Right, and you've got some products on your desk, so what are these?
So these are our pre-packed, we call them baby biocolumns, and these are the products where people usually start in research lab. And then they move up when they scale up to bigger columns, like these glass columns.
Right.
And then when they do production scale, they move up to bigger volumes, so actually do sell them in bulk volumes as well.
Right.
So we are a resin company, but we do have some pre-packed material as well.
Brilliant. Now, I know as well as talking to delegates here, you've also got some posters, is that correct?
That's correct. We actually have 3 posters here with some great people presenting them, so you should absolutely go there and check them out.
Right, so viewers, by the one technology, we're going to go over to the poster hall section now and find a bit more about the posters. See us in a second. So hi everybody, we're now over at the poster section, and I'm delighted to be joined by Mikael, who's going to give us a quick overview of his poster here at Tides Europe.
Okay. So hi, lovely to be here. My name is Mikael Andersson Schönn. I'm here to present my poster today, Purification of a Therapeutic Peptide Using an Orthogonal Method to Achieve High Purity. And in this application we have purified a 45 amino acid peptide with a PI of roughly 4.5. The goal with this application is to both show that orthogonality in your purification method, in this case using ion exchange and RPC, helps to improve the purity of your end product by increasing the selectivity of the process itself. And also in turn, using ion exchange as a pre-step to RPC helps protect your RPC column by removing impurities prior to the RPC loading. So, just to give you a bit of a glimpse into what we have done, in this figure here, you can see the purification chromatogram on ion exchange with our target marked by an arrow. And our purification chromatogram is in black here, and it's compared to purification on a competitor product in red. And we have aimed here for a total yield of 92% when we have collected fractions from this target. And if we just move on a bit down, we can see here in the top chromatogram here, in black we see the purification profile on RPC of what we took from the previous chromatogram. And in blue we see the trace of the crude itself. And you can see there that virtually all of the impurities that were present in the crude has decreased in this ion exchange step. And when loading 92% yield from that one onto an RPC column again, we get this lower one, which is the total purity that we have achieved. So basically, as I said in the beginning, we have decreased the amounts of impurities loaded onto the RPC column, while also increasing the purity of the main product. And that's in short this poster. If you're interested to see more of it, I will be here all day. So thank you very much.
Brilliant. Now we're going to move over to Cecilia, who's going to talk about her poster. So thanks a lot, Mikael.
Thank you.
And you'll be able to get this post directly from Bioworks. We'll put the link in the video. So thanks a lot, Mikael. Enjoy the rest of the
Thank you.
So with a bit of magic, we're now joined by Cecilia Unoson, who is actually one of my guests from Chats with Children this year. So if you haven't seen her on that chat, check out that interview. It's a great interview. So Cecilia, first of all, it's lovely to see you. How are you?
I'm fine, thank you.
And how has Tides Europe been for you? This is day 2, so how was day 1?
It has been really great. A lot of interesting talks.
Brilliant. Now, we're here at the poster area because you've got a poster that you're presenting at Tides. So can you tell me a bit more about the poster?
Yes. So I will talk about purification of an RNA oligonucleotide. And I should say this is a study that is done together with a customer. So our target molecule is a 45 nucleotide RNA, and it's actually an lRNA, so it has very high biological stability and it can escape the innate immune surveillance system. So it's a very good molecule to use for therapeutics. And this study is divided into 2 main parts. We have first optimization of the running conditions, where we have looked at the DBC as the readout when we change different parameters. And then we have finally done the purification where we have assessed the yield and purity. And as you can see here, we look at the DBCs, and when we change the parameter, we have the readout of the DBC. And we used anion exchange chromatography because when you have an RNA, the length will correlate to the net negative charge. So it's the perfect technique to use like that. And the optimized conditions we ended up with was phosphate buffer, acetonitrile, and we also increased the temperature. So then we saw better binding capacity and higher yields. What we looked at was also which resin to use, and what we could see was it was when you used a resin with a smaller pore size, and that means a pore size below 50 nanometer, we got a much higher DBC value. So we ended up using our own agarose-based workpiece 40Q. And we can see when we apply those optimized conditions, we got the DBC of around 56.6 milligram per ml. This RNA feed was later loaded onto the workpiece 40Q under the optimized conditions to do an actual purification. And if we look at the plots here, we have first a plot that shows the yield, and then we have a plot that shows the purity. And we can see the yield of the full-length RNA is highest in the mid-peak, whereas the purity is highest almost at the end of the peak. But the -1 species that is most difficult to resolve, the impurity is highest in the beginning. So you need to take pools and you need to cut your peak and to get this balance between the purity and yield. And we can see, of course, for the biggest pool, we have a very high yield, but at the expense of the purity. Whereas for the smallest pool, we have a purity of around 90% at the yield of 70%. So this is a compromise you need to make if you want to get a higher yield or purity, but using optimized conditions and using a resin that has properties that are optimal for your target molecule, then this compromise is less difficult to make. So that's kind of the take-home message of my poster.
Brilliant. Thank you for sharing with that. And I know you've also got another poster here as well, haven't you?
Yes.
Brilliant. And so if people want to get a copy of the posters, how can they get that?
They can download it on our homepage, bioworks.com. They can also, if they attend a conference, they can go to the homepage of the conference and then they can look at the posters online.
Brilliant. Well, there you go, viewers. So you've had a quick overview of Bioworks and also seen 2 posters from the show. So there you go. Don't say you're not getting value for money. So all that's different is, Cecilia, it's lovely to see you in person, finally.
Yes. Nice to see you too.
Yeah, well, I wish you lots of success at the rest of the conference. I know there's not a lot left, but enjoy the rest of this afternoon.
Thank you.
Viewers, I hope you found that useful. If you'd like to know more, then if you're here at the conference, you can still check out their booth and check out posters. If you're not here and you're watching this after the conference, you can go to their website, the link will be above the video, or you can check out the LinkedIn page. They're very active on LinkedIn, and you can contact Cecilia and the various members of the team directly on LinkedIn as well. So all that's time to say, Cecilia, lovely to see you.
Nice to see you.
Thank you for watching, and until next time, as always, stay well and stay safe.
Bye.